What's better than a 3D printer with two toolheads? How about one with two gantries and four toolheads? It's the latest innovation from Dr. Dan Marinescu and the team at Formbot, the Xplorer. You've heard of IDEX. This is IQEX, Independent Quad Extruder, and I've got an exclusive interview with its designer. I last spoke with Dan for the release of his first commercial project, the Marathon IDEX. Today, I'm asking him for all of the technical details of his latest creation. So stick around for insights into the mind of a 3D printer designer and an overview of this novel new printer. Hey Dan, it's great to see you again. You've been on the channel before. We interviewed you for the release of the Marathon. Now you're back with a brand new printer, the Xplorer. What is it all about, and why do you think people are so interested in it?
So is a kit one of the differences to other kits? Everything that is related to motion system or rigidity of the structure is metal.
One of the cool things about the Xplorer is that it has different configuration options. So maybe you could tell us a little bit about what those are.
So there are basically four options. You can use it as a single extruder IDEX dual gantry to print heads fighting each other, so to say. And why not also as IQEX, so basically as double IDEX. This is the modularity that I share. Of course, the platform is open to a lot of ideas. I had someone telling me I will buy this Xplorer just because I think that it would be extremely easy for me to install the INDX system from E3D. Someone saw the CAD file and realized that taking off the extruder remains with this carriage where the whole configuration needed to grab and park the extruder from a multi-tool is very, very easy to incorporate. And the back of the printer is also a lot of space where you can put 8 or 10 heads.
Very interesting. I know there's been a lot of excitement about the INDX system from Bondtech. I think a lot of people are excited by the potential of something like that. Maybe you can just speak briefly to what an IQEX printer can do, that an IDEX printer can do, that are above and beyond what a normal kind of filament changing solution would look like with a single toolhead.
That IQEX system is actually, it's shining in application where you need mass production of small and medium parts. So you want to use the print bed which you have in order to spit out as many as possible parts a day or on a working hour. For this kind of application, I think that is most suited. Of course, having 4 heads, it means also that you have 4 colors and you can do stuff in 4 color. But it's my personal opinion. If I use an IQEX, I will do for mass production. For multicolor and I don't know, the normal guy playing with 3D printing, I would take an IDX where I would put at least in one head a multi-material unit. And then you have a lot of flexibility, so to say.
Obviously, with the Toolchanger, the big advantage over a filament changing system is that there's zero waste. So I assume the same would be true of an IQEX.
Yes, yes.
But the difference there is that you could use all 4 toolheads simultaneously, right? So I know on my Marathon, I could print in copy mode, I can print in mirror mode. So do the copy and mirror modes work similarly with 4 extruders, or is there some sort of other dynamics that come into play there?
No, it's very similar. I'm still working on the software part because actually Clipper can support exotic kinematics since version 3 released, which was in April or May, so it's relative recently. But basically is very similar with IDEX. It's only the fact that you do this not twice, you do this 4 times.
So speaking of the firmware and just the overall project, this time around, I believe you put a different license on the project, if I'm not mistaken. You've certainly made some of the source available. Tell me about what the community could access in terms of this project and what they can learn from what you've done.
Okay, to your question, what is available to the community? Everything. Okay, so you have the Git repo, you have the manual, you have the slicer profiles, step files for each plastic part. Here is the system image, so everything here is stuff to download. And of course, a link to the CAD models of the printer. So basically everything. It's an open source project.
you tell us a little bit about what you learned developing the Marathon that you applied to the Explorer, and what some of the technological improvements are in the base hardware, in the firmware, etc. Anything that you think makes the Explorer kind of the next evolution from the Marathon?
Okay, what I've learned first, I really realized, or we really realized how the market is nowadays, and the Marathon wasn't really clearly positioned. Explorer as a kit has a clear destination, and also some stuff that Marathons didn't have. For example, Explorer has tool boards, so you can do the input shaper calibration. It has a chamber camera, it has a bigger hot end, a volcano hot end. It can do around 30 cubic centimeters. It has detection for filament angling. It has two motors on I-axis. The tool heads had LEDs. The calibration of the probe offsets and the X, I, and Z offset of the nozzle is made entirely automatic. It has a probe and the nozzle touches it. It has some nice macros. Print recovery. You have situation when you must recover the print. You have a power loss or you have a clogged nozzle. You can recover a print. Now, it has also a macro that does tool recovery. You start the print with tool 0, so to say, and at some point the filament runs out. The print job will be taken over by the second tool. Xplorer also has an independent homing for each Z-axis stepper motors, and also the front of the printer is very open, so you don't have in front of your eyes this beam. You see basically in all the printers that the frame is closed exactly in the front of your eyes, and the Explorer opens itself like a fridge. This is a contribution to the comfort of use of the printer.
Very nice. And just touching on one point you mentioned, you talked about power loss and the ability to recover. I believe your kinematics for the Z-axis in particular, you've redesigned that.
Yeah.
And you also mentioned a secondary motor on Y.
Yeah.
So perhaps we could jump back into that Fusion file and you could just show us around and tell us what the advantages of that system are versus the system on the Marathon or any other 3D printer.
So as I said, let's speak about I-axis. There are two motors. You can print a little bit faster. The Z-axis is made with, this time there are not ball screws anymore, there are belts. And as I said, each motor has its own end stop. And the Z-axis also makes the homing at the bottom. Why that? Because when power is lost, the bed won't keep its position. So when you recover, it homes down and then you have a leveled bed.
And just what I'm seeing on screen here is that I see a spool there. I think there was a few more that you've hidden. One of the great things about Marathon, which was one of the updates that you made from the first time I received the printer, initially the spool holders were on the back, and then you improved it and you released some files that allowed you to put the spools internal to the printer. It obviously has the benefit of keeping the footprint of the machine smaller while also potentially keeping the filament a little bit drier as it gets heated by the heat of the bed.
Exactly. That feedback, I took it very serious. There were a lot of users that said and expressed their wish that better with the spools inside. And this time I've done like the way it was desired. The spools are inside. Compared to Marathon, you can feed also from outside.
And I suppose this is taking advantage of that extra sort of space that you have, because in an IDEX system, the tool needs to move fully out of the build volume, correct? So you're taking advantage of that and you're using that to the best of your ability. So there's no dead space inside.
And of course, it's enough space to put also maybe a filament buffer or stuff like that, or here behind to put an active chamber heating system that is also enough volume for something like that.
And we haven't touched on this yet, but what is the build volume of this printer? The nominal build volume, and then the smaller area that you get when you print in some of those multi-head modes.
So in a single version, you have 400 by 400. In IDEX, when you only print with one extruder, the x-axis for one extruder reduces to 330. And then it depends if it's a dual mode is 260, when it's copy or mirror is less. For Xplorer, I provide Orca slicer profiles. You can put actually a part as big as the print bed on the bed and share the print job between the two extruder. Here I have a part, and until here is the border between the two tool heads. This part was printed by T0 and the rest by T1, and you only get this that looks like a seam line.
We'll be back with more questions for Dan in just a moment. But first, I need to thank the sponsor for today's video, PCBWay. Before you can bring any new product to market, you need to prototype it, which may require PCB fabrication, sheet metal forming, or CNC machine. All services that PCBWay offers. Simply upload your design to their easy-to-use quote generator, and their engineers will provide feedback on manufacturability. If there's any issues, they'll let you know. If not, it's off to production. So the next time you need support in your projects, make sure to check out PCBWay at the link in the description. All right, back to the interview. So tell us about the calibration and what that looks like on this printer versus Marathon. I think you mentioned that there's maybe a camera-assisted calibration. What is that sort of process?
Okay, it's not a camera, it's probe. So you have this ball, and the printer simply touches this ball on all direction, X, Y, and Z. And so are the offset measures. Of course, you have to take care that the nozzle is clean. In the printer macro, they will be heated and they will also be brushed. And the same probe is used to make the automatic calibration of the bed probe. So you don't have to do this paper process. There is a thing that must be mentioned. If you have a multi-tool concept and copy or mirror are also print modes that you use, you will have to level the nozzles physically at the same level. And this is a manual process. You have to loosen the screw holding the nozzle and you level all of them.
So essentially there's software offsets if you're doing multi-tool on the same model for multicolor, multi-material, and hardware offsets if you want to use multiple tools simultaneously.
Yes.
So speaking of using multiple tools simultaneously and their interaction, what would the resonance compensation process look like? Is there any dynamics at play when you're printing with 2 tools at the same time or with 4 tools at the same time? And how do you actually account for that?
Okay, so I start with the simple part of the problem. When you make classical multicolor, so you change always the tools, there is no issue. You make input shaper for each tool. When you do copy or mirror, it's impossible to have individual input shaping. It's just input shaper parameters adaptation in the context of mirror or copy, which are of course different to simple printing mode. Although they are the second extruder, it's always on the gantry and move, but the fact that they are moved simultaneously, that brings some other stuff.
And then when you introduce the second gantry, because the y-axis is independent, are those kinematics essentially decoupled?
Yes. When the first axis is moving, the second axis is just parked, so to say.
So for the dual gantry setup, would there be technically 4 Y motors, 2 for each?
So there are 4 motors in IQEX. You will have here in the back 4 I motors, 4 motors for I-axis. The one below are moving the first axis, which you have in single and in IDEX configuration. And when you get dual gantries, then comes another set of motors that move the gantry. The only difference is that the belts are one set of belts below and the other set of belts above this aluminum profile. The first gantry goes completely out of the bed, so it won't eat up from the bed here in the front.
So do you lose a bit of the build volume at the front if you do have the IQEX?
Yes.
Because it doesn't look like those tools can get as far off as the rear tools can.
You know, exactly. You use in the front, but in the back not.
But I recall, based on Marathon, with the slicer profiles,
Yeah.
you're actually able to visualize what the area
Yes.
is that you're going to be able to use.
Okay. So here I have an IDEX profile. This is the way the build platform looks like. I try to make it intuitive. So everything what is in the middle and says tool 0 with tool 1 is reachable by both of the tools in a dual printing mode. Everything which is from this border until the green line is tool 1, here is tool 0. And when you do mirror or copy, you just have to take care to position the part here.
So if somebody decides to purchase this, how much time are they looking at to go from the parts to a working printer?
I can build an IDEX, so from scratch to melting plastic. I can build it in 18 hours, but I am not relevant. So I would say that someone new to the project will need around 30 hours. And
I believe you said to me privately that you think that's less than it would take to put together, say, like a Voron 2.4.
Yes, yes. This is a very subjective supposition. I never built a Voron. I only looked at the CAD file and looked at the assembly manual, software run, and all that clipper stuff that have to be done. And it's extremely time consuming. And I came to the conclusion, okay, this Xplorer should actually go faster in terms of building time and setup time.
And one of the big things about building a Voron is that you have to print a lot of the parts yourself.
Yeah.
Is there anything for the Xplorer that you need to print yourself? And if so, is Formbot selling a printed parts kit?
Yes, there are auxiliary parts, brackets, fixtures. They are 3D printed. You can buy now in two versions, mechanical kit or mechanical kit plus 3D printed parts.
Very nice. What are you most proud of in terms of this project, and what do you look forward to when this gets in the hands of the community?
I'm proud that it turned out friendly. As I told you, the biggest motivation was to build a friendly project for community, and I think it turned out well in this direction. And this is the thing about I'm proud of, because when you have that kind of project, the lifespan of the machine increase considerably. Take a look. If you have built a Voron in 2020 and what happened, maybe some better boards came, maybe some better extruders, you wouldn't have absolutely no problem to upgrade your Voron from 5 years ago and still use it. This is what I want also for my Xplorer. This kind of thing you cannot say about mass-produced 3D printer. The lifespan is 1 year, 2 years maximum, and that's it. It comes a new model, and that's it.
And one question I forgot to ask you earlier, but I know a lot of people will be interested in, and I know you've had this question before, you've answered it before, but talk to us about the choice to use an unsupported rail for the X Gantry. And what can you say to reassure people that there's no issues there in terms of rigidity or stability?
First, I will show you mesh. This is my mesh from one of the Explorers. So you see the deviation for that kind of bed, in my opinion, is very small, and it's practically flat. When you have sagging because of the weight of the tool, you will have to expect to see something like this. I won't do anything more in terms of adding extra weight or extra profile. I'm not a fan of adding aluminum profile under the rail. There are different dilatation coefficients between steel and aluminum, and when going in the direction of a heating chamber, could expect some situation where the deformation is a lot bigger as an unsupported rail.
And I recall you also did some simulations back during the marathon.
Yeah.
You showed me a stress strain plot, the deflection under load of that rail, and you deemed it to be within sort of tolerance for that deflection.
Yes, of course. First, I do this evaluation of finite model element method and see what is to be expected. Of course, when you see in the simulation some stuff that doesn't look good, you go back to the drawing board and try to improve it.
So we talked about the y-axis kinematics, we talked about the z-axis, but we glossed over the actual kinematics of the x-axis. But there is something quite unique about how you've done the x-axis kinematics. So can you just briefly touch on what the x-axis actually looks like?
So what is actually to see, you have the printhead, but below the plate of the carriage is the motor that does the motion in x-axis, and the belt is the rail. So the pinion is the GT2 pulley, and the belt is the rail. It's a rack and rail motion system. And the advantage is that compared to Core XI, you have a short belt, so the elastic deformation of the belt is minimum. You only have two idlers, and the motors from X and I are decoupled from each other. So you don't get the motion by combining the motion of two motors. They are totally decoupled, and that helps when it comes to quality and artifacts.
Thank you, Dan, so much for taking the time to show us all about this project. It looks like you've put a tremendous amount of work into this. I think I speak on behalf of everyone when I say it looks very intriguing. I'm personally excited to get my hands on one. I think I might be building one here on the channel and sharing that with my audience. So just thank you so much for what you've done for the community. Thank you for putting out such a cool project that we can all get excited about. I'll just pass it over to you for a minute to say any last words, say anything you want about the project, and then maybe you can talk about how people could seek out information, where they could find that.
As a closure, the project also is intended to have some updates. One which I'm working now is integration of a cutter, that coupling it with multi-material filament to be also feasible. Also, other stuff, they will come like active chamber heating, bigger motors for X-axis. So the project is already intended to have upgrades, information, discussions. They are on Discord, so they are really active community. And I hope that this kind of users also will do interesting mods and stuff with Xplorer.
Thanks so much for tuning in. I hope you guys enjoyed that interview with Dan. I certainly enjoyed learning more about the Xplorer, and I am looking forward to receiving a kit and building it on this channel if there's enough interest from you, my audience. So leave a comment down below if that's something you'd like to see, and if you enjoyed the video, please give it a like and consider subscribing. My name's Taylor, this is YGK3D, and until next time, happy 3D printing.